All right, for all of those who have made it to the grand finale, congratulations. This has been a great forum. I'm really glad that those who did stay have recognized that this is the most important part, integration. How many times do we hear in investigations that there was a lack of communication or somewhere along the way, right? And you know, really, we're looking at what I think is the most important pieces: the hardware and the software all coming together. And we know that the software is the most important. But I'm not talking about ones and zeros. I'm talking about the pink stuff on the table here, the people. Real integration for one of these systems, as we're talking about, and we heard, dealing with highly complex, high reliability systems requires a lot of effective communications. It's not unlike what I like to compare to as a marriage. We bring different cultures and different backgrounds and different experiences, and we date a little while, and then we get a marriage license, and now everything's perfect. It's just like an ICD, right? We can have an interface control document just like a marriage license, and the marriage is fine. No. Well, those of you not married, maybe you don't know this yet. But the point is, we can't live by the document. The document doesn't make the relationship that's required to be a good system for these high performance systems. You got to live in each other's space. You got to appreciate what's important to each other. That means you actually have to talk about what's important and what you're worried about and why you're worried about it, and start building that longer term relationship. So I just want to give that preamble before we get into it, because this is how it's all got to come together. Everybody has their piece of worry, and they all have their experiences, and we've got to learn to share them and communicate them effectively. So with that, I'm looking forward to introducing each one of these folks and letting them have a little overview, and then we'll get right into Q&A. So first up, we have Jim Geffre, who is from the Orion organization, and he is the Vehicle Systems Performance Analysis Lead. He's got a lot of responsibilities relative to GNC integration, loads, dynamics, et cetera, for the capsule, which has got to sit on top of the rocket, which has to be launched from the pad, which has to be integrated in a very efficient fashion if we're going to have an affordable solution. So with that, I want to turn it over. Jim, go ahead.
Yeah, thank you, Chris. It was an excellent introduction. I hope to touch on a few of these themes throughout the course of my brief talk. I'll tell you a little bit about the Orion program, our place in the integrated stack and the exploration enterprise, and the overall exploration mission. Since its inception in 2005, the Orion project, now program, has utilized a number of integration models depending on time, circumstance, or utility. And so I'll talk about some of the lessons we've learned throughout use of each of these integration models. Next slide. This picture shows where the Orion spacecraft fits in the Exploration Mission 1 stack. What you're seeing is the Block 1 configuration of SLS. I expect my co-panelists will talk about other elements. This one is utilizing the interim cryo propulsion stage to launch the Orion spacecraft into near-Earth space. On the next page, here's a further breakdown of the MPCV spacecraft. Robert talked yesterday about the launch abort system. This one provides the abort protection for the crew module and the crew from the pad all the way up to about 300,000 feet, being able to withstand the loads and heating that comes from a first stage abort. Assuming the mission is proceeding safely, it will jettison and the mission will continue on to orbit. Below that, and covered by the launch abort system, is the crew module. Naturally, this is where the crew resides for the mission. It provides life support capabilities as well as re-entry and landing capability at the end of the mission. One of the most interesting integration challenges on Orion is the service module. So I'll talk more extensively about that. Most of you know, and we heard yesterday in Mr. Williams' talk about how we've brought on the European Space Agency as a partner in exploration. In particular, they provide part of the service module, and I'll talk about some of the challenges that we've seen there and how we've overcome them. And lastly, there's a spacecraft adapter, which provides protection during the ascent environment and connects to the launch vehicle. Next. Here's a further breakdown. We start to show some of our industrial partners in the Orion development. Lockheed Martin is Orion's prime contractor, responsible for integrating the entire spacecraft. Within that, we have what we call the ESA, or European Service Module. This is the piece that provides power and propulsion capability, rejects heat with radiators, generates power with solar rays, and provides all the in-space maneuvering capabilities. This piece is highly integral to the rest of the Orion spacecraft, which has made some very interesting integration challenges as you try to integrate such a critical element into your overall system performance. Next slide. So far, the Orion program has conducted a few test flights. Robert showed yesterday the Pad Abort 1 test in May 2010 as a highly successful demonstration of our Pad Abort capability. Then in December, a couple of years ago, 2014, we launched on a Delta IV Heavy and performed the Exploration Flight Test 1 mission, or EFT-1. This one was another type of integration model that the Orion program has utilized. So I'll talk about some of the differences between the EFT-1 integration and how we're currently operating for exploration missions. Moving on, I showed you the picture of the integrated stack for EM1. That's currently planned for 2018. After that, we have an ascent abort test called AA2. That'll be conducted out of Cape Canaveral using a abort test booster. And then lastly, we bring on the Block 1B capabilities in the exploration upper stage early into the next decade with our first crewed flight. Next chart. So the Orion program is highly geographically distributed. We utilize expertise from most of the NASA centers. Just run briefly, clockwise, starting in the upper left. Ames Research Center brings expertise in thermal protection system development. They support our aerosciences groups, G&C, mission operations, and a number of other supporting roles. The White Sands Test Facility performs material testing, oxygen compatibility, MMOD testing, and a number of other activities. Further, we will shortly ship a propulsion qualification module for the service module to White Sands. We'll do our what we call our PQM testing there. Robert also described Marshall's role in the launch abort system development. You bring your propulsion expertise in solid rocket motors there to bear, as well as ECLS and program integration. The Glenn Research Center is our lead for the European Service Module integration. They co-lead the crew and service module development, also support requirements and interface development. We utilize the large Plumbrook test facility there to perform environmental testing. It's quite a facility. We just completed our sign vibe testing there on the ESTA test article. Continuing on, Langley Research Center, again, you heard, leads our launch abort system development. There's a large water impact test facility there where we test the capsule for its seaworthiness. They also support us in a number of other disciplines like aerosciences, G&C, and others. The Kennedy Space Center is where it all comes together. We utilize the Operations and Checkout Building, O&C, for spacecraft assembly. We'll talk later about GSDO's role in ground processing. And as I said, our AA-2 test flight will be flown out of Florida. Johnson Space Center is the lead for the overall Orion program. A lot of the vehicle integration and systems engineering occurs there. Armstrong supports us in flight test development, DFI, and abort test boosters. And lastly, JPL helps with our parachute testing, TPS development, and our networks. We heard the scan summary yesterday, and JPL has the lead role there. One last center that's not utilized there, or not listed there, is Goddard Space Flight Center. Right now, we're exploring some partnership opportunities in future optical comm development. So, next chart. So since 2011, we've been in discussions with the European Space Agency on partnering in Orion development. This was initially brought about as part of ISS shared operations costs, utilizing barter to offset those costs. We reached agreement with ESA to bring them in as a partner in exploration, and since then they've utilized 13 different European countries to support the ESM development. The main prime contractor there is Airbus Defence and Space in Bremen, Germany, but they're highly distributed across Europe as well. Obviously, this kind of geographic separation introduces some new integration challenges. You're dealing with a 6 to 8 hour time difference every day, which limits how much communication can be done, via telecom or phone calls. So we've had to adapt our integration model to working with ESA, and I'll touch on some of those unique challenges here in a second. Next chart. I'll just show briefly how the Orion Program Office is organized and focus in on where our integration functions are primarily located. At the bottom of the chart, you see module offices. These are primarily hardware organizations responsible for delivering the various modules you saw. Across the middle of the page are mostly cross-cutting functions, things like program planning and control, safety and mission assurance, and integration. The Vehicle Integration Office, which is where I work, is responsible for system requirements, systems analysis, test and verification, things like specialty engineering. Our cross-program integration function is housed here, as well as various mission planning and analysis activities. Lastly, we have created a dedicated European integration office called the ESM Integration Office. They're responsible for negotiating the agreements I touched on earlier. They also have some system engineering functions located here, like requirements, but largely the ESM office relies on the technical support from the other organizations. Next chart. Okay, so at the outset, I said Orion's utilized a few different models during its time for integration. Starting in the inception, when Orion was a project under the Constellation program, the characteristics I'd define this model as would be having an increased, quote-unquote, level 2 systems engineering function with strong project participation from the ground project, Orion project, Ares 1 project at the time. Now, a change since then, as exploration has been reformulated into ESD, or Exploration Systems Development, we've relied on the programs more for self-integration. That function is pushed down to lower levels, closer to the actual hardware owners, to self-integrate. Now, that model does leave open the possibility of gaps in coverage. So there's a strong cross-program integration team with integrated task teams. These teams utilize resources that are largely owned by the programs, but report and respond to the ESD cross-program integration team. Now, with our prime contractor, Lockheed Martin, we've had a couple different models here as well. For the Exploration Flight Test 1, this was a test flight where NASA was buying data from the test. We had a very limited set of deliverables from Lockheed Martin, just a system specification, flight test objectives, and a few other documents. But still, we utilized a pretty high level of day-to-day integration and inline NASA support with Lockheed. The Orion program has utilized a streamlined oversight model where we try to maximize the amount of inline work we do. We do maintain what we think is the minimum level of oversight, but our philosophy is the best oversight comes from being part of the day-to-day work, working through the challenges with our engineers. Meanwhile, we maintain a strong system manager, subsystem manager function to preserve that traditional oversight role. Now, working with Lockheed as part of the exploration missions, we've brought on additional data deliverable requirements. EM1, EM2 will be government-led flights, so they're traditional DD-250, COFR activities, and with that comes some requirements for additional documentation. But again, we have maintained a very high level of day-to-day integration with the Lockheed team and provided inline support where the government can bring unique expertise to the task. And lastly, with the European service module, I talked about that 7-hour time difference. Well, that brings on some new challenges. Your opportunities for day-to-day integration and interaction are much more limited, so we rely more heavily on integration through documentation. Now, with both elements being developed in parallel, and as you saw, the ESM is a highly coupled member of the overall Orion spacecraft, that puts a heavy dependence on getting your requirements and interfaces right. Now, that's a challenge when you have integrated system functions, load paths that cross those modules. And so that's been one of the biggest challenges in working with our European partners has been getting that documentation right so that the end product meets the overall mission needs. Last chart. So just a few lessons learned and common themes. Chris touched on a number of these at the outset, and I think we've seen these through the first 2 days. First of all, integration needs to occur at all levels throughout your organization. While we have dedicated integration orgs within Orion, everybody needs to be responsible for integration. It's far too easy to fall into that trap that it's somebody else's job. I have my requirements, my interfaces, somebody else will take care of that. But message needs to permeate throughout the organization that you are responsible for integration. Same thing with communication. Again, this one's fairly obvious, but you need to know all your stakeholders and all your communication interfaces 360 degrees, be it across subsystems, up through your management chain, down through your teams, across to other program elements. Communication is absolutely vital, and it needs to be reinforced every day. As you've seen, I showed you 5 different integration models. We found that each one could be applied successfully, depending on the situation. I don't think we found that one single model that works for everything, but it really demands a nimble and adaptable organization. And probably the last message I'd pass along is don't confuse your oversight function with integration. We find that the integration is most successful when it's participatory, when we utilize our government engineers to engage in problem solving with the contractor. So with that, I'll pass it on to my next panel.
So let me introduce, thank you, Jim, that was awesome. You know, I like that last bullet, integration by definition is a contact sport. So you better be ready to engage, right? So our next panelist is from the Space Launch Systems Office. Johnny Heflin is the Deputy Manager for the Liquid Engine Office, aka RS-25, once before SSME, and has some particular experiences that he's going to share after we get done talking through the overview. But he's currently responsible as the Deputy for the Engine Office to manage both the RS-25 and the RL-10 integration into the SLS stack. So with that, let me turn it over to Johnny.
Okay. Good afternoon. Thank you, Chris. I'm going to start with a slide overview of the vehicle and how it evolves to 130 metric tons, and then a couple of charts on organization, because that, to me, the organization, integration is all about people, so the organization is vital, I think, to that. So we'll spend a few minutes on that. Let's go ahead and go to the next chart. Okay, we'll start on the left with what we call the Block 1 SLS vehicle. That is a 70 metric ton vehicle that is designed to evolve. The intent, excuse me, not close enough. Okay. The intent of the program from the beginning is to design a vehicle that can evolve to 130 metric tons in an affordable way. So that's what we've started with, and this is our design. So on the left, it's the Block 1 vehicle. It's a 70 metric ton vehicle that uses 4 old Space Shuttle main engines, currently called RS-25s, that are part of the 16 legacy engines that remained at the end of the shuttle program. Those are our core stage engine, along with 2 5-segment solid rocket boosters on each side. In the center is the core stage, which is the new technology, the new development program that's currently in work that houses the main propellant tanks, vehicle avionics. As you move up, you see the interim cryopropulsion stage, the launch vehicle stage adapter, and the ICPS, or the interim cryo stage. Those are unique to this vehicle. So those will fly on EM1 as part of the Block 1 vehicle and be retired at that point. And as we move over to the right on this chart, you see in the center too the crew and cargo version of what we're calling the Block 1B vehicle. The change between Block 1 and Block 1B is ICPS goes away, and we bring in what we're calling the exploration upper stage, which is a more powerful upper stage. That's a 4 RL-10 cluster upper stage engine that gets us combined at the vehicle level to 105 metric tons. That configuration can be flown crewed as well as cargoed. The final evolution of the vehicle that gets us to 130 metric tons, we go to a larger fairing to accommodate larger payloads, as well as we going to what the advanced booster. So the 5-segment solids get replaced with a more powerful advanced booster, and that gets the vehicle up to 130 metric tons. The Block 1 will fly on EM1 in 2018, and we go to Block 1B with the exploration upper stage following in EM2 sometime in 21. Okay, so that's our vehicle. So let's go to the organization. I really like this chart because it shows that they're people, right? This is the program function. And what you see across the top, of course, are the program management staff. John Honeycutt is our program manager. John brings to bear a wealth of experience coming from Shuttle. He was the external tank manager at the end of Shuttle. He's also served in about 3 different capacities within the SLS program. Very strong leader, very strong background in flight as well as in the design area. The center part of this chart really shows you the chief engineers, chief safety officer, all those other functions that make up the governance model that we operate under. The dashed lines indicate that organizationally they're matrix to the program, but functionally we all work together. We share the same office space. We collaborate. We're all in the same meetings and the same discussions. So all 3 legs of the governance model are represented throughout day-to-day operations, which really helps simplify the integration aspect of the program. And across the bottom, you see the 5 element offices. That's our level 3 function. Those are hardware-specific organizations. The solid rocket boosters on the far left, spacecraft integration and payloads, the engines. Of course, engines are in the middle. I'm an engine guy. We're the most important part of the rocket. And then you have our stage office on the far right and our ground ops liaison office on the bottom right. Those are our points of contact between SLS and GSDO at Kennedy Space Center. So very close-knit family, very, very one-team centered in terms of the organization and how we function from day to day. So that's the program side. So let's go to the next chart. This chart, I don't intend on talking each block or even telling you what the titles are. This block is really intended to show the way SE&I is managed with the program. On the far left, you have the program office, chief engineers, and the big blue bar in the middle, that's all of the SE&I function. The yellow column is what we call lead systems engineers, and then you have discipline technical managers, or the blue boxes as you move to the right, and the S&MA function on the far right column. So horizontally across here, you have programs and each element office, and what those points of contact are between the technical disciplines, the lead systems engineer, chief safety officer, program, and S&MA. Vertically, each of those functions are vertically integrated through that discipline to the program. The top bar across is the program office. So you have a program lead systems engineer. They're the level 2 SE&I function. And as you work down vertically into the element level, you have people identified that are the key touch points for all these various areas. And that's integration is all about people, and it's about those touch points. It's about having people in the right positions with clear lines of responsibility, roles and responsibilities defined, clear lines of communication. So part of the model, we have to be really lean in an era of affordability that SLS is working in. So part of that is have a lean organization, which really makes it important that you clearly define roles and responsibilities and define those communication paths, which I think we've done a really good job of doing on this program today. So that's kind of lays out our SE&I function from an organizational point of view. And just a little bit on the hardware and the progress we're making. All across SLS, all the elements are building hardware or testing hardware or some combination of the two. So we're making an enormous amount of progress toward a launch in calendar year 18. Starting in the right, you have the solid rocket boosters, the QM1 firing, or QM2 rather, which was the last qualification motor firing, occurred back in July. So that design is now in the process of finishing up its qualification and cert for flight. The next hot fire will actually be EM1 launch in 2018. So solid rocket boosters are well on their way to being ready to go fly. We'll go to the right to core stage. If you haven't been to MAF, you should go. It is a beehive of activity in working core stage. They are in the middle of building hardware. The LOX and hydrogen tanks are well underway. I think we finished the hydrogen tank that will be the structural test article. So they are making enormous progress in building hardware to get us into structural test, as well as beginning to build the hardware for Exploration Mission 1. So a lot of progress there. The small picture on the inside is the B1 or the B test stand at Stennis Space Center. That's where we're going to do the integrated stage test sometime next year. That facility is being upgraded and modernized to support that test, and those upgrades are almost complete. So they're on track to be ready to support that integrated stage test sometime next year. Moving down, we'll stay in the bottom right corner. That's the ICPS, interim cryopropulsion stage that we're going to fly on EM1. That's a Delta IV upper stage. It's a single RL-10 engine. It's currently in the process of being assembled. I think we installed the engine over at the ULA factory in Decatur last week. So that's actually well on its way to being ready to support flight. And on the bottom left, the most important part, the engines. We are in the process of testing RS-25s at Stennis. Legacy hardware, legacy engines, 135 successful flights. Very robust, proven design, but it's a new vehicle. New operating conditions, new environments, different avionics protocols. So we have to do some work to adapt those engines to that vehicle. We're in the process of testing those engines at Stennis now to prove that the engine meets SLS environments and capability, as long with certifying the new engine controller that we've developed in order to interface with the new vehicle avionics. Okay, and I think let's go one more chart. I think that's it for me. Thank you.
Looks like, again, just as in Orion, we've got a lot of hardware that is headed its way to that fateful place, KSC, where hopefully it'll all come together on cost, on schedule, even though it'll be the last, what we had a friend that had the curve for GSE. He talked about the fact that they were usually the first to be delivered, but the last to get any requirements. And I don't know, maybe that's a story that we'll hear from our GSDO folks, but I'm going to introduce Jessica Parsons. She's currently the SLS integration lead at the ground GSDO project organization, and she has been doing that for quite some time and is carrying a big load. And I've already seen some cross-discipline and cross-program integration activity that she was previously involved in. So I look forward to hearing your overview and the rest of the story.
Thank you, Chris. So, like Chris said, I'm from GSDO. What I wanted to do was talk about GSDO because, again, a lot of people don't know about the ground. We're not as important as the vehicle, but everything does come together. Do wanted to give a brief overview where we are today and also how we do that cross-program integration because that's critical, for the success of the enterprise. So I'll be getting to that. For those of you that don't know, GSDO is the Ground Systems Development and Operations Program, big name, and we're responsible for upgrading the KSC infrastructure and developing the ground systems that are going to build, process, launch, and recovery SLS and Orion. So with that, I'm going to go through some slides of the progress that we made today. Let's go to the next slide. And I will say that Pat Simpkins did steal a lot of my pictures and probably his story was probably more interesting than what I'm going to tell you today. But if you weren't here yesterday afternoon, this might be new to you. So here's the mobile launcher again. This was heritage from Constellation. So we finished completing the tower. And where we are today is we're installing the GSC throughout the structure. It's about 35% complete today. In the middle, you see some of the testing Pat mentioned yesterday from our launch equipment test facility. That right there is the OSMU, the umbilical service module, umbilical, the Orion. And up in the top corner, we got the TSMU, the tail service mass umbilical, which is one of our largest umbilical that's going to be providing locks in LH2 to the core stage. Next slide. Here's the progress we made in the VAB. Again, like Pat mentioned yesterday, we've been installing the platforms. We're about 80% complete, and we're getting ready. Once that's complete, we're going to be doing the functional testing, which is the retraction. What I really like is the bottom right picture because you can start seeing the automotive line of the vehicle. So it gives you, a perspective of, what's coming, what's going to be integrated in the VAB. Next slide. This is some updates that we're doing in the pad. We have to do some catacomb ceiling reinforcement, and we're also strengthening the crawler tracks and the pad surface to handle the SLS weight. Obviously, it's a much heavier vehicle than shuttle, so there's a lot of upgrades that we still have to do in that area. In the next slide, this is the MPPF, a multi-payload processing facility. This facility, we made it a clean room facility. This is where we're going to do the hyper servicing for Orion. And right now we're doing VMV testing in a lot of the systems of that facility. So you can go to the next slide. I not only wanted to show those pictures, just to kind of give a progress of where GSDO is, but I wanted to emphasize that this hasn't only been the effort of one program. It's been the effort of the 3 programs in ESD because, in order for us to figure out where we wanted to locate the platforms, we needed, those interface requirements to be worked across those programs. The GSC, some cases we need GSC delivered from the other programs to make sure that they will get integrated into the mobile launcher. Same thing with, the umbilical plates that are supporting the testing in the LETF. Those are critical deliveries that are coming to GSDO to support our schedule. And just like the other programs, we're all still in a DDT&E phase But like somebody said, we have to be ready at the same time the vehicle is ready. So it's definitely some challenges. So now I'm going to talk about how do we do that cross-program integration. Again, it's really essential for GSDO because this is where everything gets physically integrated. It's the first time the vehicle is going to be assembled. It's the first time we're going to be seeing interfaces together. It's the first time we're going to be powering up the whole vehicle. And we have to test everything to make sure that supports launch. So that's our emphasis. And today, we rely on the CPAD model for cross-program integration. That's what, as part of ESD, that's the model of integration that we have across the 3 programs. So I think John's going to talk a little bit more about, how the CPAD works as part of ESD, but the CPAD models, you're not familiar with it, it relies on ITTs, or integrated test teams, which they have emphasis on developing a product. It's a system engineering product. And so we have multiple ITTs within that structure that have emphasis on ground processing, and they're led by the GSDO rep. For example, if you look at that virtual org chart, you will see like launch integration teams, OMRS team, ground hardware integration, logistics. Those are all teams that had emphasis on ground processing and are led by somebody from GSDO. Another thing that we do as part of the cross-programming of the CPAD model is that each program has an SE&I lead, and those leads work closely together and proactively to make sure that, we're identifying and addressing the high-risk items. I know they have like weekly telecons where, they'll talk to each other, and if we run into a problem, I know they're picking up the phone and talking to the other program, working together. Other things that we have within GSDO are integration engineers that are the technical representatives to SLS and Orion. Like that is my job today. And we help provide cross-program integration, program-to-program integration during the different phases of the vehicle. So we're responsible for the interface management. We're also getting ready for how we're going to be supporting EM1 processing and operations. So we're going to be leading the technical integration for when a problem arises during the process and how we're going to, deal with that troubleshooting, how we're going to be working with the other programs for that. We work heavily on the OMRS, which is, the operation requirements, how they're being developed, making sure the language that's coming from the other programs is clear and we can understand what the requirements are and that operational requirements that we have to implement. Same thing with LCC requirements. And at the end, all these requirements also have to be incorporated into the software, so make sure that the application software has adequately implemented those requirements. Next slide. So wanted to talk a little bit about a few of the lessons learned since we had this cross-program integration. I will say that having a cross-program integration team and not an independent level 2 integration office, I believe it allows us to work together, closely. It doesn't, usually I would say during Constellation program, if we had an issue, we will just elevate that issue to level 2 and let them work that problem. So now we don't wait for somebody else to solve that problem. We work, call our sister program and try to figure out how can we resolve that problem? What is the best solution that we come up for the enterprise? Let's see, also it drives us to, look at the perspective from the team that's working the issues. If we have an issue between, the vehicle and the ground, we try to optimize that solution, try to figure out, what's the most cost-effective, schedule-effective solution that we can come up with. And there's several examples that we've gone through. I could think, for example, model test was one of those things that we looked at, where it was adding several weeks on the ground schedule to perform that test. But also it was a high cost item to go do a full, IGVT that they did during a shuttle program. So, we had to come up with a solution that optimized the enterprise. And we took, a couple of weeks schedule hit on the ground, but ultimately it's something that will benefit the enterprise overall. Another thing that I think we've done is that we have each of the programs participate in our major life cycle reviews. And I think this has been essential to help identify technical issues and disconnects early in the process. So, if Orion had a PDR, CDR, you had GSDO reps and GSDO engineers that were reviewing those products. And not only that, but we were also providing joint products that supported that review. We also work agreements on dependency directly with the programs. So like I mentioned, we need GSC delivered, we need plates delivered, we're gonna need the flight hardware delivered on time. All of these are dependencies that we're working closely with the other programs and identifying that need date and what's the effect if we don't meet that need date and how can we go off and mitigate that. I also said one of the challenges we have is, each of the programs have a different funding profile, therefore it leads to a different schedule. So that's probably one of the hardest things to manage, that, we like to have hardware delivered at KSC a lot earlier, but, some of the other funding profiles may not allow that, so we have to figure out how to mitigate and manage that. And lastly, I will say that I think this integration model allows for quick decision velocity. If we run into an issue, we have 3 JICBs weekly. That's a joint integration control board where the 3 program chief engineers make technical decisions. So we elevate that issue. And if can't come to resolution, the next week we're at the program managers, the JPCV, the Joint Program Control Board, trying to come out to an answer and mitigation for that problem. So I think this really allows, quick decision velocity. I think somebody yesterday said that during Constellation or another program, it was weeks or months before an issue got to go through the boards. I think this really allows, quick decision making. Next slide. So I wanted to talk a little bit about kind of what are those successes that we had from cross-program integration today. I'd like to say that, to this date, we feel confident that we have defined the GSC that's going to be provided by the flight elements to GSDO, and have reached agreement on the delivery dates. As part of that, also we conducted heritage assessments. So we have a lot of hardware that's coming, that was used in shuttle. So what we do is perform cross-program heritage assessments to make sure that hardware is supportable. Another thing that was key was to make sure we had a clear understanding on the acceptance requirements. So we did develop an acceptance data package, across programs acceptance data package plan, and have an understanding of what data is going to be coming with each of the flight hardware elements once it gets delivered to the ground. We've done successful planning for the integrated test and checkout testing. So this is all the major testing that are going to be happening at KSC. Anything from, modal testing, wet dress rehearsal. These are the big tests that would only happen once the vehicle is totally assembled at KSC. So we have developed the requirements, come up with test plans, and work closely with the other programs on how we're going to be developing the procedures to support those tests. Another thing that GSDO is responsible for is, landing and recovery. We did successful landing with EFT1, and, we have had several underway recovery tests to help with the validation activities in support of EM1 and kind of build that confidence. Right now, we're doing a URT5. And that only doesn't need integration with the Orion program. It's also integration external of NASA with the Navy to make sure we have those resources, make sure we communicate what our requirements are. Other things we've been working on is we define all the roles and responsibilities after the hardware gets turned over or posted D250 to KSC, trying to figure out how the design center is going to support what we're processing the vehicle. If we run into an issue, how are we going to be processing the non-conformance? How are we going to involve the other programs to help us write procedures? So all those roles and responsibilities were recently defined and documented. And obviously the most important part of, building this rocket and getting everything processed, it's launch. That's what we're there for. It's to make sure the launch is successful. So we develop a strategy and the detailed planning of how we're going to be conducting launch operations, define the launch team roles and responsibilities, who's going to be supporting in the flying room. We've done a lot of, we reached an agreement on the timing and sequencing of events that are going to happen as part of the launch countdown. And obviously, this is closely integration that has to happen between all of the programs. And last but not least, somebody mentioned software. And, software is really a big challenge across the enterprise. And I will say the biggest challenge is the fact that, each of the programs have an agile software development process. And it's really hard to integrate that. But I think what I will consider one of the successes is the fact that we have been able to identify the dependencies of what each program needs and when that information is needed, so we can meet that agreement and that deliverable to make sure that overall we succeed as an enterprise. So that's all I had for today.
Great overview. That really gives us, I get really excited when I see these three things. In 2011, we landed the last shuttle. And this is the end of 2016. We're right on 2017. We're getting tight on actually flying this launch vehicle. The gap between Apollo and shuttle is almost exactly the same. So I'm really, really proud of the schedule that we've been able to maintain given these large developments that we're undertaking. Let's jump right next to our next presenter, which is Jennifer Reed. And she is in the ESD organization. She's responsible for the human rating and system engineering that's going on. And she's got a title that I'm really curious about, which is Integration Scientist. And we talk about rocket scientists, and I think they're more like rocket doctors because they practice medicine. We practice rockets some more than we do science. So I'm interested in the science part. But I would really look forward to hearing your overview on the ESD, and then we'll get right into questions.
Okay, first thing I'm going to tell you about integration science. One of my first jobs with KBR Wiley was working in the human research program and trying to figure out transition to ops, all the really amazing things that the human research program is doing to mitigate the human system risks that we're actually trying to design for today. And so that's where that title came from, and I really need to change it to integration engineer, but I didn't get a chance to do that yet. So a little bit of both. As Chris mentioned, I have a really unique job, and I love it because half my time is spent helping implement NPR 8705 for the enterprise, which is the human rating NPR, and ESD is one of the first programs or enterprises to implement that NPR. So there's a lot of lessons learned and benefit for us doing that. And then the other half of my hat is system engineering support. And through that, I get to do risk mitigation. I'm the book manager for the ESD SEMP. I'm the ESD Lessons Learned coordinator. I work on open work and a little bit of everything, actually. So with that, I have no hardware. So we can jump into the first slide. So here is the construct for how ESD is set up. And really what you see are two separate teams working together. You've got the programmatic and strategic integration, the PSI, and they do things like the life cycle review programs, the budget, the schedule, and programmatics. And then the cross-program system integration is really what I'm going to talk about today because that's where I live, and that's where we do the technical integration. And this model is a new model, and everybody touched upon it a little bit, and I'm really glad that they did because they made my job a little bit easier. And it's a new model coming out of lessons learned and budget from Constellation. So during the Constellation program, we had a really strong you might say top-heavy, depending on how you look at it, system engineering function, level 2. And we could not do that with this program. And so what we've done is set up a cross-program integration team that leverages the programs to lead and develop the integrated products. And then we also have a model for communication and decision-making that leverages the same construct. And Jessica mentioned the JICB. So let's go to the next slide. This is going to be the best org chart you've ever seen because it's a rainbow. And the reason why it's rainbow is to give you a feel for the cross-program nature of who leads all these teams. So what you're going to see is at the top you've got the cross-program system integration leadership, and you have the CPIT leadership, which is made up of members of ESD. You've got the chief engineer for ESD is in there. You've got the ad hoc teams, you've got safety, you've got the technical authorities, you've got some side teams, and then you have below that these blue boxes, and these are the functional area leads, and we actually call them the blue box leads. And so what you see is somewhat of a system engineering construct set up to cover each of the areas of focus for integrated products that the enterprise will need to build. And so you've got system safety, system engineering, and that's actually where I live. I support the system engineering functional area lead, and then underneath that, I'm the deputy for human rating. So it's a great place for me. And then we go all the way across. Praveen's here. He's the integrated design and analysis functional area lead. System integration, Jessica has quite a bit of experience there. That was an area that she was involved in. Interfaces, and then mission management. So you can see by the colors, ESD is CSI led, green is SLS CSI led, and pink is Orion. I think it's supposed to be red, but I'm calling it pink. And then yellow is GSDO. So one of the things that you'll see is there's also a logical flow from left to right as we moved from where we are in the life cycle to where we move towards closer to ops. And so you see the mission management. And so one of the great things about what we do with the CPIT model is it can grow or it can retract as we move through our development cycle. The ad hoc teams you can see up there, those are short-lived. They may not be product specific, but they sometimes actually an ad hoc team can turn into an integrated task team. One of the areas that we've actually changed is with system engineering and requirements management. We actually had a ConOps and requirements team that after they developed and we had a good set of requirements and a ConOps, we retired that team and then moved our focus more into the enterprise V&V. Some of the newer teams that have come up, mission management function has grown over the last few years. We have a mission manager for EM1, and then we also have some growth in the areas of launch integration, landing and recovery, and those are the main areas that stick out. Let's see. Let's go to the next slide. So this is just kind of a diagram that talks about the integration functions and how the construct of the CPIT is set up to facilitate both horizontal and vertical. And probably it's best explained by some examples. And so one of the things I can talk about is, I'll talk about what I know, which is human rating. And part of the human rating team is we, like most of the integrated task teams, we have program reps. And each of the program reps that come and support our task team are supposed to be empowered to represent their program. They provide inputs to the products that we develop. If there's an issue associated with the product that we're developing, they take those issues back and they support the up and out sort of explanations and issues and reporting out that we want to do. At the same time, you can have two ITTs that are dependent on each other for inputs. So there's an ITT that talks about that's crew survival, and the crew survival product is actually an input to human rating. So not only do you have dependencies that between hardware and software that Jessica alluded to, and those are managed by an interdependency process that we have, which I think is a great innovation for ESD. But you also have the working together of each of these products. There's an XPRAT, which does the programmatic or the probabilistic risk assessment, and that, again, is another input into the HRCP. And so you have this communication going all over the place, and it kind of looks crazy, but it's not. I think the important thing, she's laughing, it is, okay, it's a little crazy. But I can't remember. I made a note because it said integration is, this is Jim, integration is most successful when participatory. And so by each of the programs and having a CSI rep participate on each of the ITTs, everybody gets to touch the products while they're being developed. So not only do you have collaboration when you build a product, and some of the examples would be the IRDs, the ICPs, the human rating cert package, COFR, Health and Medical has a crew health ops con and MedOps requirements documents, design analysis. So there's probably, I'm going to guess and say there's 50 products that we would call integrated products. Then you go through the CM process with those products. And again, each of the programs in the enterprise are linked together and get a chance, again, different folks come in and touch these products for goodness. And then, like Jessica alluded to, we participate on each other's life cycle reviews. And at ESD, what we try and do, we have an opportunity, since we're an enterprise, we kind of have to modify and adjust how we do our life cycle reviews with 7123 in order to make it make sense. So same thing with human rating. If you look at the human rating NPR, you see the words, the program manager shall. Well, for me, that's Bill Hill shall. So when it comes to the life cycle review, it's the same thing, and so we modify things. But the participation that at the program reviews leads up to an integrated sync, and so we've called them, instead of saying PDR, we'll say design to sync. Instead of CDR, it's a CDR equivalent, and we'll call it build to sync. So one of the challenges associated with that is the schedule. So you have 3 programs working independently, but also collaboratively. But when it comes to managing life cycle reviews, you have to look at the big picture, and when things are being done, you can't look at like Orion doesn't put the Orion to GSDO IRD as part of their life cycle review if GSDO has just had it done. So there's some logic to what we touch and what we look at. But it's sporty. And as we come up on EM2, one of the challenges is we really are focused on EM1, but there are some design differences and upgrades associated with EM2. And so one of the lessons learned with regards to integration is to leverage this construct that works and retain the flexibility that it has. At the same time, start looking at what's going to be different for EM2 and what do we need to do differently. I like GSDO as an example because even though they have their pad and they have their facilities and all the things that they need to do, just changing the stack a little bit changes how they have to do everything. And so all the analysis that goes into access and things like that is something that has to be taken into account. Let's see, I wrote down a couple other notes. Communication, when it comes to communication, I think it's been a recurring theme, how important that is as part of integration. So it's not only product driven, which is what you ultimately want these ITTs to do, but you facilitate the communication between the 3 programs and up and out through the FALs up to the CPIT. And so the CPIT leads, I'm pretty sure that I know that they talk every single morning And then they have weekly tags. CPIT has a technical forum where they status technical topics and action resolution. We have, at the ESD level, the CSI gives a status to the ESD leadership every quarter. The programs also attend. And most recently, they've started including some of the key contractors as well. So I think that's really good. Let's see, do I have one more slide? I might not. I don't.
Great, excellent. Thank you, Jennifer. You gave me a really great question that I'm going to ask. Well done. I want to also very quickly get to the audience questions. So if you've got a question, go ahead and get your hand up so that we'll get a mic over to you while they're answering this question. So you used a rainbow chart. I love that. But you know, to have a rainbow, usually there's a preceding storm. And I guess since we're actually here trying to share more than our successes, so that we can learn from each other, I'd really value you guys being willing to talk a little bit about some tough issues that you had to work through and how that went. So I'll open it up to the panel.
Well, I'll go first. And this is just personal experience. One of the first jobs I did supporting ESD was being support to the Health and Medical Tech Authority. And one of the early things that they need to do is work with the programs to implement a standard, NASA Standard 3001, which is the health and medical standard. Each program, the work that we leveraged previously with Constellation, so there's two sides of it. You've got the health and medical, the health standards, health and medical, and then you have sort of the performance, human system integration, human factor standards that are in a different volume. And for Constellation, those requirements were flowed to Constellation through the HSIR, which is the human system integration requirements. But when it came time for 3 programs to stand up, the decision was made that as long as you meet the intent of what is in the HSIR, then you also meet the intent of Volume 2 of the standard. I wish, that's just me personally, I wish we had just kept it and made it a cross-program document. It's not impossible, but it is different. So one of the challenges when it comes to integration and flowing down requirements is traceability, right? And so I think initially there was some challenge trying to make sure that all the human system integration requirements were implemented by the programs, and we're there now. But I think it was a little more difficult than just saying. That said, at the same time, it's very appropriate for programs to push back. That's part of how you stay lean, right? And I'll use SLS as an example. In some ways, SLS is an induced environment on Orion when it comes to the crew, right? So the HSIR has requirements that relate to vibration loads and acceleration loads. And so it made sense for SLS to say, we accept these acceleration limits. We will put those into our spec. However, it makes more sense for us to do a TPM with regards to how we meet the vibration loads and make sure that we provide that information over to Orion, because ultimately Orion is responsible for mitigating at that interface if they need to. So that's just one example.
Great. Jim, you look like you.
Sure. I think with any new enterprise, especially when you're trying new ways of doing things, there's bound to be growing pains. And with the ESD enterprise, the same thing applied. So I think I touched on communication as being a critical lesson learned in my brief talk. And I would point to that again as one of those storms we had to work through. Jennifer talked about daily communications between the CPIT team organizations. We established that as a regular business rhythm. Sometimes you need to force that communication at the start, and then it just kind of grows organically. The same thing with the European partners. We had to force the communication at first, and then eventually once that trust builds and that partnership grows, it becomes a more regular part of your business. So probably the biggest lesson learned is early communication.
Again, consistent with the marriage analogy. Johnny, you got anything?
Sure. I think being an engine guy, we have a little bit of a unique position in terms of integration because both our engines have been designed for some time, right? So we brought the SSMEs from Shuttle and now RL-10s that have been in production for 50 years. SSMEs were designed in the early 70s. How do you take that heritage hardware and meet all the integration requirements, design and construction standards, all those things that are written almost from a clean sheet design perspective, right? So working with the SE&I team within SLS and with CPET up through the vehicle to really develop a process for tailoring requirements to go look at what the intent is. Something we really learned coming out of the Constellation, developed a process for tailoring requirements in a very rigorous documented way so that you apply the intent of the requirement rather than asking a contractor to build something differently to meet today's requirement when it's flown SSME 135 times, RL-10 a bunch, right? So we know it works, we know the design works, but the process of negotiating through all the integration aspects of how you do that and how you satisfy all the stakeholders and meet all those requirements is a real challenge that I think we're benefiting a lot from the Constellation program and the ground they plowed in order to do that as part of Constellation. It's really serving us well within the SLS program today.
Okay.
All right, and I'll just add, one of the challenges, I guess, from the GSDO perspective that we encounter is, kind of that concurrent engineering that we're trying to build and, design, build hardware at the same time, the vehicle is still in the design phase. So I can think of one example with hardware with Orion, not to pick on them, but where we were, designing our ECS system, the PAD, the vehicle, PAD ECS system, and we were using a lot of the requirements that were in the IRD from Constellation because you were making the assumption that a lot of those requirements hadn't changed, and I believe those didn't really come, they didn't get updated until like the Orion PDR, so we were getting ahead in our ground design, and when we actually got those requirements from Orion that were very different and had an impact on what we had built already for the ground, and we're getting ready to go into the V&B. So we had to work really hard with Orion to scrub those requirements, trying to figure out, the difference that we had in trying to figure out there was a way we can mitigate it in the vehicle or what could mitigate on the ground. I think ultimately we got to a few areas that we still had disconnected and that we had to end up upgrading the ground infrastructure for it. But, it was kind of one of those lessons learned and challenges that, we do have. And it's kind of like, we got to have our ground systems ready the time the vehicle shows up.
I think that's a great example, and it makes the point that I was trying to do in the earlier comparison to the time between Apollo and Shuttle. If we'd have tried to actually have all the requirements in a daisy chain mentality, we will be 2015 before we get ready to fly, and so we had to take some risk, and people are going to get exposed when we take risk, and so I think that's a great example of how, and work through it.
Yep.
KSC, you guys are really good at making diving catches all the time. So
if I can just add, though, that's one of the things I worry about between EM1 and EM2, because talking about plowing the way and making assumptions, there are some definite differences. So that's one of the things we're starting to really talk about, and I'm glad, it's not just EM1 again.
Right.
And so we may see some of those similar things.
There are still some risks as we're in the development program. So I think there were some questions that got started.
So I want to follow up on what Jennifer just said, and you actually touched on earlier. If you look at how we're developing Orion and SLS, where we have a set of vehicles that are enabled by heritage parts, and then they get reborn again with new engines, new SRBs, new boosters, and maybe Jim could tell us what actually is going to be the future for the service module, because I think we get 1 or 2 with the Europeans. I'm not sure what the deal is right now. But as we go through the progression of these vehicles, it's not just EM1 and EM2. If we get a different service module or different version of the service module, that could be EM3. When the SSMEs run out, I think that's after EM3, or maybe after EM4, I can't remember how many engines we have. There's a whole new core with a whole new set of engines on it. Has there been any probable risk assessment associated with these changes going through the series of launches, where we might want to consider maybe not making that a crewed mission? Let's demonstrate a bunch of these new capabilities together as a cargo mission. Do we know when we push this insertion of new components too far? That's a question for all you guys.
Well, have at it.
Okay. Yeah, I'll try to touch on a few examples. First, you asked about the European service module. So right now we're working on finalizing agreement for the second flight model. However, we want the Europeans to be a long-term partner in exploration. And we have laid out a longer-term roadmap for upgrades along the way. I think it was Nigel yesterday who gave an example about the serial versus parallel propulsion system. So we have laid in an opportune time where we think that upgrade can occur. And to your question about safety analysis, well, that was part of the discussion. If you fly a serial system for your first couple flights and then switch over to a parallel system, is that first version truly safer than the one you're replacing? While I'm not sure we have resolved that issue, all I can say is it's been a very significant part of the conversation, and it will be going forward as we plan the next couple flights.
So I'll tag on to what I said a little bit earlier about the heritage hardware. You talked about bringing that mix in. It really, to me, it's all about test and how you demonstrate that hardware meets requirements. So you mentioned the advent of the RS-25s. We have 16. They will run out at the end, or EM4, and then we're bringing new production engines online. That will go through another rigorous test program, certification program, to show that that engine meets the same requirements. So we work that at the element level. At the vehicle level, I'll be honest, it can be a distraction at times, right? You've got a lean team. It's a great problem to have, but you have a lean team working, and you have to really be diligent and cognizant as leaders to make sure the teams are focused on the most important task throughout the day. You have to keep an eye on the configuration changes, certainly, and how you go through and verify that all those changes are being accounted for and the risk is acceptable. It can be a real challenge, and it really, I think it's one of the issues that we really have to keep our eye on as managers going forward.
If I can just add about that, you talked about, flying things for the first time in a new configuration versus, maybe having an uncrewed flight first. And that is something that we look at. And, one of the risks that we have in the system at the ESD level is any potential for test gaps related to that. So as soon as Orion chose to defer ECLIS, there was from EM1 to EM2, the test like you fly topic came up, and it was a big concern for multiple stakeholders like the crew and health and medical, and so each program is kind of faced with that same challenge. Orion or ECLIS is a good example for Orion. EUS is a good example for the SLS program. For GSDO, there's changes to the stack. There's the emergency egress system. There's some comm and some other things. The landing and recovery, a little bit of some of the GSE there. So you do have to take all those things into account. And I talked about one of my things doing risk mitigation. There's an ESD risk in the system that each program is getting comfortable and right with how they're doing T&B. Orion did a fantastic job of capturing, I think, like 18 items of concern with regards to their T&B, and over the past few years has been knocking them down, ECLS being one of them, to the point where that particular risk, the residual risk is going to be accepted by the program, and, the risk de-escalated down to VIO. The challenge is going to be for ESD to be able to show Bill, okay, here's Orion's acceptable risk, here's SLS's acceptable risk, here's GSDO's. So here you go, Bill. Here's the integrated risk associated with flying EM2 in this configuration versus, how we're doing EM1. And so that's something that we definitely are watching. And sometimes I proposed another risk for EUS just to look at those things. So it's a big, important thing. And it's gotten a lot of attention all the way up to the ASAP and the NAC. And so we'll continue to
So I think
be vigilant.
The conclusion, it's definitely something that is talked about up front during the development activities and is still on everyone's radar. That's the job of the program management team, really, is to be making those assessments and presenting it forward. So another question.
Yeah, Ronnie Lawson from KSC. Having worked on the station program since 20 years ago, and hearing a lot of what you guys are talking about just brings it all back to memory about what we went through, and the hardware to software integration, the international partner communications, the whole thing. And I would just ask, have you guys done the knowledge deep dive to look at the lessons from what we went through in station, all our integrated testing that we did at KSC, and the hundreds and hundreds of reports that we wrote from that?
Why don't you start, Jessica?
I'll start. I can tell you, yeah, definitely we have obviously a lot of GSDO engineers in management that come from ISS. I was one of them. But one of the things we've done, and I could tell you, is the lessons that we had, during testing and OMRS, the operations maintenance requirements. We had actually, a person that worked in ISS. He's working now as our OMRS panel lead. And, there's a lot of lessons he captures about the way the requirements were written, when we had PRACA that we had to take, the number of PRACA that had to be taken. I think it was hundreds of them because the requirements were not written well. So those are lessons that we are bringing today when we're SLS and Orion are developing OMRSs, and try to make the other programs understand why it's essential that we have clear requirements laid out, because we don't want to get into processing and start, having all these non-conformances because the requirements were not clear. So that's just one example I can think of. I think there's, a lot of other lessons on like integrated testing. Obviously, we're going to be having those major integrated testing. So some of the planning for that we have taken into account. Make sure that we're testing what is needed to be tested, not, to the nth degree, because we can make testing, a science project, but to make sure that, are those objectives that are like, that have high risk, that we really need to make sure that we understand how they perform when the vehicle is integrated. So definitely done that.
Jim, you got anything relative to international?
Yeah, sure. I think, first of all, like Jessica just said, there's a number of members of the Orion management and engineering staff that bring that firsthand knowledge from ISS, either from the International Partners Office, the test and verification teams, the list goes on. So there's that firsthand knowledge that they're directly imparting into program decisions now. The second thing I'd point to is, after the cancellation of the Constellation program, there was an extensive knowledge capture and knowledge learning activity, which both the projects and the program undertook at that time. So I think we are fully utilizing ISS lessons learned there.
Yeah, I was going to agree. Great. So we got time for one more, I think. Anybody else got a burning question?
I don't know if it's burning, but I guess primarily for Jennifer, I was just wondering, you talked about the integrated risks, and I was just curious, how does the arm wrestling for the budget go if you actually want to do an initiative to buy down an integrated risk?
So I guess what you're kind of touching upon is the balance of cost, schedule, technical, right? Anytime you get an issue. There are opportunities to make better, to buy down risk, and I'll talk about one of the going back to the risk of the first crewed flight. If it makes sense, people will do it. And I think Orion has a great example of making some changes where they could to EM1 to buy down risk for EM2. They added a hatch. There's discussions about, versus having a mass model to actually fly some seats. I don't know if that made it to the MPCV this week or not. But the challenge is we're getting to a point in the life cycle that it's more difficult to implement those kind of choices. But I think those are some examples. Oh, adding some testing, adding some modal testing and things like that. They are going through and making conscious choices to, at a cost, to buy down risk. We're sticking to our schedule, and that's been a hard thing to do. The technical challenges, I think, are going well. So, does that answer your question?
Yeah, I guess I was just, I guess it's primarily integrated testing, but, just if there's kind of an overall system level, not, for the entire stack. I mean, something that you could focus on more effectively from the, the cross-program integration perspective, as a risk reduction effort.
With regards to integrated testing?
Yeah, or...
So I think, GSDO is kind of leading that effort with the ITCO ITT integrated test and checkout. So I probably can't answer that as well as you'd like.
Yeah,
But
I
Jessica
can
might be
help
able
you a
to.
little bit on that. So we did have under the CPED one of the ITTs is the integrated test and checkout team. And the first task they had was to go off and, work with the programs to understand what are those high risk items that needed to be tested when the vehicle was assembled. And they come up with, multiple test objectives. Some of those things, for example, are like wet dress rehearsal. We wanted to, buy down the risk at the launch countdown. So we need to understand, how the vehicle performs during the launch count and how far down do we go, do we want to take the risk? So, I think we decided that we needed to go down to like T-minus 9.3 seconds or something like that because, that was a critical point that we got a lot of, buy off of understanding the launch countdown. So that's one example. Like she mentioned, modal tests. Modal, we decided that was one of those integrated test and checkout tests that, we're really doing a lot of model validation for EM2. We're trying to use that data to do a lot of the model validation. So we try to understand what were those requirements and make sure that, if it was important enough, it was probably high cost. I think I mentioned it earlier from a schedule perspective. There was also partial modal tests, which again, it was kind of giving more confidence in that loads data. And we made a ESD level decision that although that was a hit to the schedule, we were going to incorporate it because it was one of those high risk items that we wanted to buy down.
Yeah, I think that's a great summary. And again, this program is definitely a lean program. There's not extra vehicles in place to be used. The core stage is going to be acceptance tested, and then wet dress rehearsed, and then flew. So it's it is something that the program has to consciously decide about whether more test is actually going to use up the life of the flight vehicle or not. So I think our panel has done a great job of giving us an overview and a deep dive on some of the things they've been doing. So let's give them a big hand.